Hey everybody, Mr. Barry here. We're on the back side now of the notes here when it comes to higher degree polynomials, graphs, and zeros. We're taking a look here at end behavior now. It says at the top, end behavior, where the graph is traveling to on the left and the right side. So we're going to be looking specifically at the arrows here at the end of our images. I did give you the same exact chart at the top, and I'd like you to go ahead and draw those pictures in if you could. So if you need to push the pause button on this, please make sure you do that so you can draw that on. We want to spend some time here talking about end behavior, and specifically in these problems, take a look at what we can see here. So linear, that line we saw in Algebra 1, quadratic, parabola we saw a lot of times. And basing our looks off of that, we need to understand here that something occurs when I take a look at the odd number polynomial function. So 1, 3, 5, linear, cubic, and quintic. And you could take a look at this. This arrow is going down. This one's going up. Down, up, down, up. And then finally, when I go to the negative a value, up, down, up, down, up, down. So when I have a polynomial function that is odd, and again, we're talking about our highest degree that we see there, 1, 3, and 5 there, the arrows, the end behavior would be going in the opposite direction. Certainly will help us kind of quickly go through these problems a little bit more. When we have the even numbered, so 2 and 4, probably the highest we go there, would be our quadratic and then our quartic. They're heading in the same direction. They're heading in the same direction. Up and up, down and down, up and up, down and down. So it's going to follow that process no matter how far we go here. Of course, we're going to spend most of our time just with these 5 right here. So to point out what happens there, our end behavior, I want to always make sure that I kind of focus on what's going on the right side first. It's just kind of easier to think about it this way. If our a value is positive, so the a value here is positive, the right side, no matter what, if the a value is positive, the right side is going up. I'll abbreviate. Then we follow our type of polynomial function rules here. Is it going to go opposite on the left, or is it going to be the same exact thing on the left? So if it's odd, it's opposite. So it means left, I'd be down here. And for all the odd numbered polynomials, we're going in the opposite direction. For all of our even numbered polynomials, we know that we would be going in the same exact direction. So if it's up to the right, it will be up to the left also. Same thing happens with the negative. We just know that if we start off with the right, down, 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 no matter what, if my a value is negative, to the right of the graph, we're always heading down. So if my a value is negative, we're always heading downwards on the right side. We got to base what happens on the left side for our type of a polynomial rules. We know that if it's opposite, the left would be up. For our odd numbered polynomials, and for the right side, for our even numbered polynomials, we'd have the same exact thing directionally happening, which means if our right side is going down, our left side would be going down as well. So a lot of information there about our end behaviors based upon what type of a polynomial function. Is it odd or is it even?